Hello guys, now we already know the basic feature of STP and also some basic configuration. Now we can use the STP to provide the function to avoid the loop and also can provide some backup link, right? In this video, we will talk something about the advanced feature. The first one is port faster. Advanced feature means if you don't use this feature, STP also can work. But if you use this feature, maybe it can make your network better. And what is port faster? As we know about the STP, if finally we select one rule to become DP or maybe to become RP, they still have to waiting by default is 30 seconds. And one on the listening status, we have to wait 15 seconds to let the whole network do the convergence. And in the learning status, we have to wait 15 seconds to let all the switches learn more MAC address table. But in some special scenario like the topology, if we use the terminal to connect with switch, as we know about the terminal, there is no loop because about the switch sends a message to the terminal will not forward to back to the switch again. So in this scenario, finally we will know this interface connect with the terminal should become the forwarding status. So if we still waiting 30 seconds, this is the time waste, right? In this scenario, we can make the interface to become port faster. And if we add the configuration of this feature, we can directly skip the 30 seconds. Of course, this is a default time. If you change the forwarding delay, like the example of the configuration to become 18, you can skip 36 seconds. And if you make the interface to become port faster, then the interface can directly enter into the forwarding delay, into the forwarding status and to forward the message. If the port with this feature also receives an BPDU, then the porter will enter the forwarding status after 2 forwarding delay times. So what's the scenario? Maybe you make the switch 1, the first interface, to become port faster. And as the planning, you have to use a terminal to connect with the first interface. But finally, maybe some mistake, someone used the switch to connect with this interface. So if the switch sends out the BPDU, then this interface will sync. In order to avoid the loop, I will delete the port faster feature. So we still will do the convergence like the STP principle, and we have to waiting 2 forwarding delay time, 30 seconds. So this is a function. And the command is you have to enter the interface and enable the spanning tree port faster. It's very easy, but pay attention. If you make sure the interface is connected with terminal, like some access switch, right? You can enable this function. Otherwise, it's no need. Because if you directly connect with a switch like the distribute switch or maybe some access switch, the upstream interface, this interface, if it receives a BPDU message, this feature will be discarded. Okay, so this is the first feature. And the second feature is BPDU guard. The BPDU guard is once a port that should not receive the BPDU. For example, you already make the interface to become port faster port. And in this scenario, if we receive the BPDU and you already add the BPDU guard, then the function will immediately shut down. and the port, and we will set the port status to become error disabled status. In this mode, the interface can send out the BPDU message, and we can do the convergence. Okay, and we can have two configuration modes, one for the global. If we enable the feature in the global mode, it will come into effect on all interfaces with port faster config. So if some interface don't add the port faster feature, this one also cannot work. If the port faster is turned on for an interface and the interface receives a BPDU, maybe someone uses the wrong connection with switch, right? The port will enter the error disabled status. So maybe you can check if you found the interface status is error disabled. You maybe have to find the troubleshooting is you maybe some switch is connected with the port faster interface. An indicator that a network device may have been added into the network by an illegal user, causing the network topology to change. So, if the interface to become error disabled, the original network will not do the calculation again. Otherwise, we will do the recalculation. So we will delete some MAC address table and to calculate the topology again. This also is a resources waste. And the command is on the global configuration, use the command spanning tree port faster BPDU guard default. This is a command. And another mode is interface mode enable. Turn on the BPDU guard for a single interface. This is independent of whether port faster is configured of the port or not. In this case, if the port receives a BPDU, it will enter the error disabled status, although maybe you don't enable the port faster in this interface. It doesn't matter. But about the global mode enable, only working for the port faster port. And the command is enter the interface, spanning tree BPDU guard enable. This is the second one. And how to recover the error disable? About the interface mode, you have to shut down and use no shutdown to enable to recover the correct status. About the global mode, error disable recover will directly finish after 300 seconds. So this is error disable. Otherwise, the interface cannot work. And the next one for the BPDU filter. And the BPDU filter can filter out BPDU received or sent on the interface. So you can directly maybe discard the BPDU and also cannot send out. And also have two configuration mode. One for the global mode enable, we can turn on the global BPDU filter function. In this data, the interface will with port faster enable will neither receive or maybe send out the BPDU. And if the port faster receives the BPDU, then the attributes will be directly discarded. The BPDU filter will also be disabled automatically. And the command is spanning tree port faster BPDU filter default. And about the interface mode, if you enable this function into a single interface, this one also is independent whether the port faster is turned on or not. In this case of the interface, neither receives BPDU or send out the BPDU, which is same to turn off the STP function of the interface, and the interface will directly enter the forwarding status, like You don't enable the STP function on this special interface, but the rest of the interface still can working like the STP. And the command is enter the interface and then spanning tree BPDU filter enable. And the next feature is about the TC protection. Do you still remember what's the TC message? If the network topology is changed, the directed devices will send out the TC BPDU, right? This one we also call is TC message. And then the root bridge will send out some special configuration BPDU and makes a flag to become one of TCN and TCA. Then the next step is we have to calculate the topology again and to delete some MAC address entry to shorten the time from 300 seconds to become maybe 15 seconds, right? And if some special scenario, we have some attacker and make some TC BPDU message and send in our network. And this is attack. And in this scenario, you will find all the time maybe the MAC address table is empty. So in this scenario, we hope we can provide some TC protection. And of course, if we have some attacker of the TC BPDU, some layer 3 switch, it also will trigger a repass operation of the fast forwarding mode. And the special table of the ARP table entry also will be changed. So if we hope we can avoid some above operation being frequently done when the switch is attacked by some special TC BPDU message, and finally to make the CPU overload, or maybe your network is not so stable, you can use the TC protection. And if we enable this function, when the corresponding function is turned on, only one deletion operation will be formed within a certain time, and the default time is 4 seconds. That means maybe within 4 seconds I receive multiple TC messages, but I only delete the table once. And after 4 seconds later, if I receive one, I would continue to delete the MAC address table. So in this scenario, we can protect the CPU resources and also can protect our MAC address table. And the command is on the global configuration, we have to use the command spanning tree TC protection. So there are 4 advanced features you can use on the STP protocol. And last, there also is a practice questions. Which of the following description of the STP interface status is incorrect? The first one, in the blocking interface, can we receive or send out the BPDU? If we in the learning status, what's the status? And if we in the listening status, what's the different? And the last one, if the blocked interface does not receive the BPDU within a certain period of time, it will automatically switch to listening status or not. So please tell me the correct answer. If you want to know this one, please see the next video. Thank you.
Now let me have a brief summary for you about the STP training video. Why we need the STP? That's because we want to get the redundancy function but also want to avoid the loop. So this is the main function of STP. So why the STP have this function? That's because about STP we will select a root bridge. And then every interface we have the rule, like the RP, like DP, and the AP. because finally we were blocking the LNet port. And about this blocking, this is a logic blocking. That means if one link is broken, the blocking interface still can work. And then we talk something about the STP advanced characteristic. For example, how to make the network faster and how to calculate the network topology if one link is broken. And about the last one, we explain some key configuration of the STP. If we want to enable the STP, what's the command? If we want to change some parameters, what's the command? If you want to do more practice, maybe you can see the next video. Thank you.